Scientists just discovered a new force of nature, and it changes everything. We've long believed we had a solid grip on the forces that govern our universe. Gravity, electromagnetism, the strong force, and the weak force. These four fundamental interactions were considered the building blocks of all physical behavior, from how stars burn to how atoms bond. For decades, the standard model of particle physics has explained nearly everything we observe with remarkable precision. But something strange has been happening in labs around the world. In highly controlled experiments, certain subatomic particles have been behaving in ways that defy expectations, as if an invisible hand is influencing them, unaccounted for by any known force. Now, after years of data, calculations, and repetition, scientists believe they may have uncovered what could be a fifth fundamental force of nature, a discovery so significant it might lead to an entirely new chapter in modern physics. 1. The known forces and their limits. Before diving into the new discovery, we need to briefly revisit what we thought we knew. The four known forces are: gravity governs the attraction between masses. It's the weakest force but dominates on cosmic scales, holding planets, stars, and galaxies together. Electromagnetism, responsible for electricity, magnetism, light, and chemical bonding. It powers our modern world and operates at atomic and larger scales. Strong nuclear force binds protons and neutrons in atomic nuclei, the strongest known force, but it acts only over very short distances. Weak nuclear force, responsible for radioactive decay and crucial in nuclear fusion, the same process that powers the sun. These four are what physicists use to explain everything, from why your phone screen works to why the universe hasn't collapsed. But there have always been gaps. The standard model doesn't explain dark matter, which makes up most of the universe. It can't fully describe gravity at quantum levels, and it has no framework for unifying all forces into a single theory. So the question has persisted: are we missing something? The Muon G2 experiment, a clue from the subatomic world, the mystery began gaining momentum through a particle called the muon, a heavier cousin of the electron. Like electrons, muons spin and have a magnetic property, but they're over 200 times more massive. This makes them highly sensitive to external forces. At Fermilab in Illinois, scientists were conducting a precise test called the Muon G2 Experiment, designed to measure how muons wobble when exposed to a magnetic field. According to the standard model, this wobble, or G factor, should be perfectly predictable. But when results were analyzed, scientists found a significant deviation. The muons were wobbling more than they should. It wasn't an error. The results were repeated, and each time the muons seemed to be interacting with something unknown, something beyond the four known forces. This something was subtle yet unmistakable, suggesting the existence of a new, unidentified force at play. 3. Is this the fifth force? So what could this be? Physicists are cautiously referring to it as a fifth force of nature. While it hasn't been fully characterized, early data suggests it could involve a new fundamental particle, potentially a boson that mediates interactions like how photons mediate electromagnetic force. One hypothesis is the existence of a Z-prime boson, or even more exotic particles linked to the so-called dark sector, a hypothetical realm of particles and forces that interact very weakly with visible matter, but might govern dark matter and cosmic structure. Another possibility is that this force only interacts with certain particles, like muons and not electrons, which would help explain long-standing anomalies in particle behavior. If proven, this would break the symmetry of how we understand particle families and force a total rewrite of the standard model. 4. Why this discovery is taken seriously. Science demands skepticism, but this discovery is gaining traction due to several key reasons. 5 sigma confidence. The results reach the gold standard in physics. 5 sigma, meaning there's only a 1 in 3.5 million chance that the data is random noise. Replication. Multiple runs of the experiment, including earlier ones at Brookhaven National Laboratory, found similar results. Independent anomalies. Separate experiments in Europe and Asia, such as those at the LHCb at CERN and the Atom Key Institute in Hungary, have observed related anomalies that hint at the same underlying force. Theoretical backing. Numerous theoretical models had already predicted such behavior. Now the math is beginning to match the data. We're not looking at a one-off experiment. This is converging global evidence of something truly profound. 5. Dark matter, hidden particles, and new physics. Why does this matter so much? Because the fifth force may be a portal to the dark sector, the unseen part of the universe that includes dark matter and possibly dark energy. Dark matter is known to exist because of its gravitational pull, but we've never been able to observe it directly. This new force might interact with dark matter, providing the first concrete way to study it in the lab. It could also help us understand why the universe is expanding faster than expected, why matter dominates over antimatter, whether time and space behave differently at extreme scales. In short, this fifth force could open up new physics, like discovering an entire wing of a mansion we thought we had fully mapped. 6. The human side of scientific discovery. Beyond the technical details lies a more human story. This discovery reminds us of how limited our understanding still is, and how much we have left to learn. For centuries, each generation believed they were nearing complete understanding. Newton thought he had explained gravity completely, then came Einstein, and now quantum physics. But again and again, nature humbles us. This fifth force is a reminder to stay curious, to embrace the unknown, and to never assume the story is finished. 7. The road ahead, what comes next. The scientific community is just beginning to explore the implications of this new force. Over the next decade, we'll see next-gen particle colliders. New accelerators, such as the proposed Future Circular Collider, FCC, could test fifth force theories with even greater precision. Advanced detectors, better muon detectors and neutrino observatories will play a critical role. Theoretical expansion, physicists will refine mathematical models to unify this new force with existing physics. Technological ripple effects. New physics often leads to new tools, inventions, and applications. Quantum computing, space propulsion, or even energy breakthroughs might follow. In other words, we are standing at the edge of a new scientific frontier. 8. Why this matters to you. At first, a new subatomic force might seem like something that only matters to scientists, but discoveries like this eventually shape the technologies and tools we use every day. Think of how electricity, once just a strange curiosity, became the backbone of our entire modern world. In the same way, understanding a new force could lead to advanced energy solutions that are more efficient and powerful, medical innovations like precision imaging or targeted therapies, revolutionary communication systems through quantum technology. Even if you're not a physicist, this discovery affects you. It signals that there's still so much we don't know, and that tomorrow's breakthroughs might completely reshape how we live, work, and interact. Most importantly, it reminds us that science isn't finished. We're still learning, and every leap forward opens new doors for innovation, progress, and possibilities we haven't imagined yet. 9. A new mindset for the future. This discovery isn't just about particles, it's about how we think. In a world full of rapid change, the fifth force is a reminder that knowledge is never complete. Even the most accepted truths can evolve. What matters most now is a mindset that stays open to questioning, to learning, and to growth. Whether you're building a business, learning a skill, or creating something new, it pays to think like a scientist. Stay curious, explore the unknown, and never assume the limits are fixed. The fifth force reminds us, real progress begins where comfort zones end, and those who adapt will shape the future. A discovery that changes everything. The possible discovery of a fifth force of nature marks a turning point, not just in science, but in our collective understanding of reality. We've only scratched the surface of the universe. With each new finding, we peel back another layer of mystery, and with this, we may be on the verge of something truly revolutionary. So keep your mind open. The universe is far more complex and far more amazing than we ever imagined. If this journey through science and discovery fascinated you, don't forget to like this video, subscribe to the channel, and leave a comment with your thoughts. What do you think this fifth force really is? Could it be the bridge to dark matter or something even more profound? Let's discuss below, because one thing's for sure, the story of the universe is still being written.